Hi, and welcome to an overview of the latest features shipping with the exciting release 5 of 3DEqualizer4. This release is packed with new functions and scripts, so we picked the best ones to demo them. Be prepared and let's start with the updates to the 3DE4 UI. Release 5 was downloaded and is waiting for us, so let's start it. The first thing we notice is the general overhaul of the UI. It got a bit darker and cleaner than before. Text fields, option menus, tabs, handles, most UI elements were moderately redesigned to preserve the typical 3DE4 look and feel. A big topic during the redesign process was increasing space for content. The separator bars of all panes are now just half their previous size, resulting in a noticeable increase of space in both panes and display area. Further, scrolling bars are invisible if the pane's content fits into it. It only appears if needed, so with a smaller pane width, we get a bigger display area. Next, selecting got an exciting new feature. This feature will be shown with all these points on the wall in 3D orientation. Top view. And go. There are so many reconstructed points in this project, but assume we like to select the points forming the curved wall alone. Traditionally, pretty annoying. New in Release 5, 3D features a Lasso selection tool. Holding keys Ctrl and Alt, it is possible to draw a selection shape selecting everything inside of it. Now it is easy as pie to select structures like this wall. This will save a lot of time. Great, all points of the wall are selected. This tool isn't bound to 3D orientation controls. We can use it everywhere items can be selected. Of course, in every other controls like lineup and manual tracking, as seen here, and in editors like Curve Editor and Deviation Browser. Alright. Panes got an interesting update as well. To be more precise, which panes we can add to display area. As usual, a typical pane like Curve Editor. Now it is possible to add Python scripts as pane as well. No more windows floating beside or beneath the main window. All your favorite patcher tools and many others can be organized right within 3DE4. Of course, not all scripts make sense as a pane. Those which open their own window not blocking 3DE4 can be selected here. To get your script ready to be added as panes, simply a single line of code has to be added to existing scripts. Please refer to the latest Python documentary in section Tech Docs at 3DEqualizer.com. Okay, there's a nice setup containing several script panes. Of course, such an arrangement can be saved as an environment. As usual in Window Configure, we can save a pane arrangement. Environments now became more individual and personal than ever before. We can set one for any possible step in our workflow, so easy and so fast. Further, as known from previous releases, when closing 3DE4, the latest arrangement will be saved, independently from the latest set environment. After starting 3DE4, all panes appear again. From one big workflow update to another, even bigger one. We added so many scripts we hardly can see the content and display area. Especially if there's a huge 3D model or many 3D points. It can be a bit frustrating seeing only a bit at once, if we do not like to zoom out drastically. Introducing Hide Panes in Release 5. A simple click on this button and boom, all panes disappeared and we have a clear view at our content. That was fast. Okay, so again, with panes and with a clear view at the content. To make it even simpler, by default, shortcut Tab was assigned to this button. So with a single key press, hide show hide. Of course, all functionalities of the open panes, like delete from point browser, are not deactivated and still accessible from the hidden panes. That's it with the exciting new interface of 3DEqualizer4 Release 5. Redesigned UI, lasso selection, script panes, environment, and hide panes. All these new features help to work faster than ever before. This chapter is about improvements of the 3D solver. Say hello to dynamic point weighting. Here we have a project with one not so perfectly tracked point, messing up the otherwise great reconstruction quality in a certain range. Having a closer look at this point, we clearly see the cause of the peak in deviation. A bad 2D tracking in said range. Of course, we could simply retrack the point in these frames, but let's assume for this demo there is no chance to improve 2D tracking. Simply disabling the point in the given frame range can cause an unstable and shaky camera movement if there aren't enough other points to compensate the sudden lack of tracking information. 3DE4 Release 5 provides an option to handle such problems. Have a closer look at updated parameter point weighting. And welcome the new option, Dynamic. Let's see what changed and what we can do now. First, obviously, static weight cannot be edited anymore. In Point Browser, the edited point is labeled as dynamic. So good so far, but where can we now set values for dynamic weight? The answer is Deviation Browser. Let's open a second browser for a better overview. Good, now hide average deviation curve. Next, select Show Point Weight Curves, selected points only. A yellow line appears. Its look is pretty the same in those of previous releases, but from now on we can edit this curve like in Curve Editor. Having a look at the deviation curve, we see 3 CVs are needed to weight the curve. 1 CV with value 0 in the peak frame, and 2 additional CVs at frame positions before and after the peak. Expand the lower weighted frame range. Great. For more precise positioning along axis Y, let's enter the CV position values manually. Our middle frame should be exactly 0. And the other 2, you might guess it, 1. So they're matching with the other point's weighting value. We noticed in Release 5 it's possible to edit position values of multiple points. Script Edit Curve Keys was redesigned from scratch and now works on all curves in Curve Editor as well as Deviation Browser. Calc the project. And here we go. Perfect. We got a clean deviation curve. The advantage of a dynamic weighting curve compared to simply disable the point within the badly tracked frame range is the soft transition. As mentioned earlier, simply disabling a point might lead to a shaky camera movement. Further, if there aren't enough other tracking points available, it is recommended to set the lowest CV slightly above 0 to prevent this point from becoming passive and not contributing to the camera reconstruction. Alright, next up on the feature Rollercoaster, forced calculation. What do we have here? It's a nodal shot of a green screen filled with markers. Well, to be precise, as we can see by the yellow rod, it's a near nodal shot. Nevertheless, there are tracking points available, so let's calc the project. Deviation value looks good, like the curve itself. Well, until the last frames. It seems 3DE4 couldn't calculate anything in the end. Let's expand Point Browser and have a quick look at the calc status of each point. There are some points which only could be triangulated by 3DE4's solver. When selecting them, we see these points are all tracked in the last frames of the sequence. So, we have the cause of our problem. Release 5 introduces an exciting new option to force the solver to calculate a point. Sounds cool, right? In the point's attributes, we can find a new parameter called Triangulation Behavior. Here we can set this behavior to force full point calculation. Now, after calculating the project, we can see this calc status was set in Point Browser. And more important, According to Deviation Curve, the solver was able to reconstruct the camera in the last frames. So let's change the triangulation behavior of all remaining points to give the solver no other possibility than take each point into account. Perfect, we got a nice curve. That's it with the two best 3D solver improvements. Dynamic point weighting and force calculation give us powerful options to handle problematic projects. Welcome to improvements for object point groups. Release 5 has impressive new features for handling object tracks. Let's start right away with the demo. This shot shows a handsome guy holding a blue box. Everything was reconstructed correctly, as we can see at Deviation Curve and white geolines on the box. So, let's switch to 3D orientation. This demo is all about the point group path. More precisely, how this curve is depicted in Curve Editor. With the point group selected, let's open Z Editor. Then select one of the position curves. Pause Z, for example. We see the translation curve in Z direction. Now, if we scale the point group, we quickly see the point group path moves in Z direction and even changes its shape accordingly to the transformation. After releasing the mouse button, we notice a changed path. But the path in Curve Editor remain unchanged. These curves are normalized object point group moves relative to the camera transformations. So scaling an object in global space won't affect the curves in Curve Editor. In Release 5, it is possible to show curves as they really are. Now we can edit them as they appear in global space. Select View, 3D Rod Path Curves, Show Curves in Global Space. A new curve appears, and as we notice, it is now much closer to the curve we see in Display Area. This time the point group is scaled, all transformations are depicted correctly and immediately in Curve Editor. It doesn't matter if the path or even certain CVs are modified in Curve Editor or within Display Area. Both curves are synced and behave identically. Okay, now we're getting to an extremely interesting feature, optimizing the Z-depth of point groups. Yes, 3DE4 finally provides a way to handle distance-related errors of object point groups. At first, let's have a quick look at the shot. We see a blue box in front of a green screen filled with markers, which was lifted and put back down by a mysterious person. We can see as well, everything was already reconstructed. Let's have a look at the reconstructed box in 3D space. Something's looking strange. We remember the box was standing still on a chair, but nevertheless, there's a noticeable tremble. Shake it like a Polaroid picture. This tremble is a common problem for object point groups. Even more if the object is far away from the camera and therefore really small in the footage. The deceitful aspect about this tremble can be seen back in Lineup. Zoom in for a closer view at the box. Okay, to be precise, we see this aspect by seeing nothing. When looking through the camera, the tremble is not noticeable since it's really small. Such a small movement towards and away from the camera is really hard to see. Nevertheless, the data in 3D space speaks a different language. There is an annoyingly shaky box that should be fixed. Release 5 introduces the completely new Object Point Group Z Distance tool. By the way, beside opening this tool as a pane, we can find it as well in menu Edit and as a button in Display Area. Okay, back to the tool. If a point group is selected, we can see a curve depicting the Z distance towards the camera. Select another view option to frame the entire path. Good. So, what's the curve telling us? In the middle, there's the part where the box is lifted. Having a closer look at the beginning or ending part, where the box is supposed to stand still on the chair, we clearly see the shaking. Okay, so now we have a great and precise possibility to visualize the box's trembling. The best thing about this visualization, we don't have to worry about the point group's individual rotation and position curves. This curve solely shows the Z distance towards the camera, so editing it keeps the other rod path curves consistent. Enough theory, let's start editing and see what magic happens. Moving SCV down leads to a box movement towards the camera. Moving it up, you might guess it, translates the box further away. Everything's clearly noticeable here, so let's switch back to lineup. Put the entire box into display area. Okay, then move SCV. We see nothing. As mentioned, these movements are simply too small to be seen with a human eye. Luckily, with this script we can optimize the curve for a perfect result. One quick tip. If the curve was modified, the originally unedited version of the curve is displayed as a thin line. Get back to the original status. Okay, in order to reduce the tremble, let's filter the curve. Select all CVs belonging to this part. Then enter a filter value and click Filter CVs. Nice, we got a smooth curve. Let's check the box in 3D orientation. The curve structure already indicates it. The tremble changed to a box, well, slightly swimming through 3D space. So we know this box doesn't move since it stands still on the chair. Delete all selected CVs. Great, now everything is fine. Check again in lineup. Marvelous. Now hard numbers and visual appearance are on the same page. No movement in any view. Before we move to the middle part, let's quickly fix the first part the same way. Select all CVs. Then delete. Here as well, no trembling after the edits. And in 3D orientation. Perfect. As a last step, let's check the middle part. Here, the curve suddenly leaves at a certain frame. Have a closer look at the box in global space around this frame. As indicated by the curve, the box really jumps from one frame to another, instead of moving smoothly like in the footage. In this case, a tiny tracking error was sufficed for this behavior. Nevertheless, obviously, this entire bunch of CVs has to be placed above its current position on axis Y. Instead of doing that manually, Object PointGroup Z Distance tool provides a cool feature to seamlessly integrate these CVs into the rest of the curve. With all needed CVs selected, click Edit, Patch CVs. And boom, perfect. Finally, since we still see some trembling across the entire movement, filter all CVs. A lower value might be better. Then have a look at the shot. At first here in 3D orientation. We fixed it. The trembling at beginning and end is gone, and on top, the overall movement of the box is more calm and moves like in the footage. To complete this chapter, have a look again in lineup. Here as well, nothing to complain. Everything smooth and fine. All edits didn't affect the visual quality of the reconstruction. Even more, the movement is now correct in every view. We've seen two amazing updates to object point groups. Global space and the incredible new Z distance tool will be a great deal when working with object tracks. Release 5 brings a huge update to 360-degree shots and changes the way VR projects will be solved in 3DE4. Are you ready? Let's quickly get to know them. At first, have a look at the shot. We see two guys performing some badass karate moves. Everything's filmed in 360 degree. I wouldn't want to meet them in a dark alley. Obviously, the first thing to mention here is 3DE4 Release 5 can read and play 360 degree sequences instead of only a still. As in Release 4, we need parameter group long lat conversion for the next step. Button long LED conversion changes the view like we would see through a normal non-VR camera. Resolution sets the footage's resolution in display area. Focal length controls the focal length of the virtual camera. The possible range is very wide, but in this demo, a value of 100 is the right choice. Next is, wait, there are two parameters missing. Pan and tilt are gone. Okay, not really gone. They were moved to a different place, with a very good reason. Open Curve Editor. Scale it since we'll focus on the curves in the next step. Here we see a new entry called Long LED Conversion Curves. Expand it and great! Here are the parameters previously located in Attribute Editor. So why were they moved here? Now it is possible to create dynamic pan and tilt curves. Yes, we can animate the camera in 3DE4. Simply create one or more CVs to adjust the camera's rotation. Such an animated camera is vastly useful for object tracks. For example, if the karate guy should get another face. So, to demo this exciting feature, let's say we like to follow this guy and make sure he's always approximately in the middle of the image to track his head later. To follow the actor, the camera has to pan. So the recently created CV on curved camera pan should be around 30 degrees in the beginning. Good. Then around, let's say 100, we add another CV and set it to a value of roughly 150 degrees. Our guy is back in frame. Nice. In such a short time we animated the camera. A quick tick along the path. Yep, the camera follows him perfectly. Of course, the second kicking master shouldn't be ignored, so the camera should move back and follow him until the end of the shot. A little adjustment to reduce the panning speed at second CV. Cool. Have a look at the camera movement. As if we would have been on the set and captured the footage as we see it. Nice. Well, now we do have a camera movement, but how do we track features to get the camera in 3D space and 3D point positions? Of course, we can search a feature and track it throughout the shot. Release 5 awaits with new features to help us here. Be prepared to be amazed. Please welcome converting points from regular to long LED converted. Switch back to the regular view of the 360-degree shot. Then choose any features and place a 2D tracking point on it. And I really mean it, any feature. Considering the current camera movement, we concentrate on the left half. In a world record time, we got a dozen of points. Okay, we have some points, but back in long LED converted view, these points of course do not stick to their positions we chose in regular view. With a single click, this can be fixed. Select Edit, Convert Regular to Long LED Conversion. And 3, 2, 1. Awesome, isn't it? All points snap to their correct positions and stay there throughout the entire shot. All points got correct tracking curves. Again, with a single click. Due to the curves in Curve Editor, 3DE4 has precise information of the camera movement. Therefore is able to calculate the 2D tracking curves of each point. Tracking a VR camera was never easier. Of course, this function works flawless if the footage was filmed with a fixed camera position. If the 360-degree camera rig moves within the scene, features have to be tracked as usual in long LED view. There's nothing else to do, so let's calc the camera. Set a fixed camera position constraint, then calc all. Uh-oh, deviation doesn't look good. What went wrong? Obviously, the tracking quality isn't the problem. Maybe the current lens causes this error. Like in tab lens, we also find here a parameter called horizontal angle. Keep the 100 degrees in mind, then switch to tab lens. As we can see, both parameters have completely different values. The virtual camera was set to an angle of 100 degrees. Therefore, the footage seen in display area effectively was like filmed with 100 degrees. Like solving a normal shot, if the lens does not match with the material, we get an incorrect solve. But here in VR, an elaborate adjustment procedure isn't necessary. We already have all infos we need. This parameter simply has to be set to the same 100 degrees as in tap camera. Then calc again. Wow, what a result! There isn't any calculation error or inability to calc the shot. If camera and lens are matching, we really get a deviation of 0. The perfect result. Let's check the result in 3D orientation. Nice. Points and camera movement were reconstructed correctly. For a final check, let's add a 3D model. Choose a point on the floor. Then let's add a cube and snap it to the selected point. Switch to lineup and play the shot. So, with just a few clicks, in like 2 minutes, we successfully animated a VR camera and reconstructed 3D points and the camera's position in global space. Now we would be ready to track the actor's face. This chapter is about how to correctly use both convert point scripts in case the camera movement should be modified. We see a camera animated with a new camera pan curve in Curve Editor. Further, a point tracked on the actor's face. This point was tracked in mode long lat converted. The advantage of tracking a point here instead of the 360-degree regular view are the distorted edges of such a shot. In long lat converted, there is no such distortion and the karate guy always stays undistorted in frame. After tracking, we suddenly realize the camera movement isn't satisfying. The ceiling should be more visible. But changing the camera obviously will make our tracking point obsolete. Instead of tracking again, and this point was really mean to track, 3DE4 Release 5 provides a new and easy way. Previously we had points in regular and converted them to long lat converted. This time we do it the other way around and convert the points from long lat converted to regular. Select Edit, convert long lat conversion to regular. And here we go. The point is back on the actor's face. Within the entire range, this point was originally tracked. Now we can edit the camera as wished. Since the ceiling should be more in frame, curved tilt needs to be filled with some CVs. One at the beginning. Then let's say around 50, the camera should look up a bit. Good. Back to regular. The point is still where it belongs. In a regular view, changes of the camera, of course, do not affect the points. The camera's animation is ready. We can convert it back to long lat converted. Switch back to long lat converted. And when playing the sequence, we see our point is where it belongs. A big advice. If we should have altered the camera movement without first converting the points to regular, there is no chance for 3DE4 to convert this point correctly later. It always uses the camera curves in Curve Editor for the conversion in each way. Always make sure all points are converted to regular view before editing the camera. We are staying with topic VR. This chapter is about camera rigs. We have a project containing several cameras on a VR rig. All cameras have tracked points, they are synced, and each has an individual lens attached to it. And since this isn't complex enough, there are some 2D points just seen in a single camera. But in the end, everything could be reconstructed as we can see. Of course, there is no impressive feature without a big problem. Zoom in and center the cameras to have a closer look at this problem. We can see all camera movements are not really steady to each other. Each camera moves individually, not something you would expect having a rig with fixed cameras in it. To prove the visual appearance, numbers are always a good choice. Add script, camera differences to display area. A quick introduction. This script calculates an average camera of all existing ones in the project. The values display position and rotation of the three axes, X, Y, and Z. The rod path values of each camera are in relation to the average camera. So, have a look at camera objects and values. All numbers are going wild, like the cameras in global space. It's so shaky that it's not deniable this shot wasn't solved yet. Since there shouldn't be any movement, how do we fix the current chaos? Release 5 introduces a script, adjust Piggyback camera constraint, and it will be very helpful. This script uses the calculated average camera to force a virtual constraint in each selected camera. This virtual constraint adjusts the position and rotation curves in relation to the average camera. So, with all cameras selected, open the script. In the appearing window, we see the path rod offset values of the selected cameras. The position and rotation of the average camera is displayed in the curve widget. Here we see the average camera's movement throughout the entire shot. Like in all curve widgets, all CVs are editable. Alright, we like to adjust translation and rotation offsets of the selected cameras, as set by default. Button OK transfers all parameters to parameter adjustment. So let's open it. 7 cameras with 6 parameters each. Well, this will be a lot of work for the solver. Adaptive all and adjust to start the adjustment. After some time, we got a result. Transfer all values. By the way, say hello to 3D4 Disco Lite. Patent pending. Have a look at the camera group in display area. All cameras were adjusted in position and rotation. Last, the project has to be calculated again to adjust 3D point positions. Great. Pick one camera to center it. If we now play the shot, we see everything is steady. All cameras do not change their position towards each other. Finally, we have a correct rig. And that's it with VR. Pretty big update, right? Camera animation, converting points to and from long lat, and Piggyback. These new tools will help so much solving VR projects, only with Release 5. This chapter demonstrates the new features and enhancements of orientation controls. Let's start with 3D models. At first, we need such a model. More precisely, a big one. Like this car with a count of over 500,000 polygons. When navigating around the model, we see everything smooth, no matter how fast we change the view. Just the look of the model changes during navigation. 3DE4 Release 5 can handle large 3D models way better than ever before. When importing big models, 3DE4 automatically detects the size of a 3D model, and if the new option, Performance Rendering, should be activated. To demonstrate the old performance, deactivate Performance Rendering. We see everything's laggy. Not so pleasing than previously. So, better activate this feature again. The performance depends on the render capabilities of the built-in graphics card. Here you can control the quality of the model during navigation, so even if a slow card is installed, a fluid workflow will be possible. Working with large models was never more comfortable than in Release 5. Next, we're moving on to texture mapping. For a better demonstration, a different model will be imported. 3DE4 automatically detected the model size and lets performance rendering deactivated in this case due to its small size. Release 5 introduces a new option for texture mapping. Beside the already known footage projection, now we have the possibility for texturing with UV maps. We don't have any map manually imported for this model. What can be done with button UV map? So the human is rendered with a solid gray color. Further, the 3D model we imported contains no information about UV coordinates. Well, we cannot do anything about the texture right now, but about the coordinates. In Menu 3D Models, we find New Script, generate UV coordinates. Here, in 2 simple steps, one for setting a projection orientation and one for the scale, we can generate simple UV coordinates for the selected 3D model. If no texture was imported, a checkerboard is mapped by default. Looking good, but we won't stop here. The famous script Lambertizer, downloadable from scriptdb at 3DEqualizer4.com, was rewritten from scratch and implemented natively, which drastically enhances its speed. So, for those who aren't familiar with the script, what does it do? It creates a Lambert shading effect for the selected 3D model. In the upcoming requester, we can adjust the appearance of the effect. OK, to apply the effect. Nice. The model is looking more vivid and reveals much more details than before, thus enhances the possibilities for a visual check of reconstruction quality. The next demo shows a scenario. The described functions will be helpful. Here we have a mocap project, already solved, showing a reconstructed moving head talking something. As seen clearly in display area, until now we only could project the footage on the mesh created from reconstructed 3D points. So to apply the things we learned previously, set parameter texture mapping to UV mapping. UV coordinates were already generated, and we don't have a texture imported for this model either, so we see an accurately mapped checkerboard. So good so far. Checking the model in lineup, we see, well, the checkerboard. And at least that it moves pretty accurate. But we cannot see anything from the face, which isn't very helpful for checking reconstruction quality. So, back to 3D orientation controls, then to Lambertizer. You might have noticed, beside contrast and brightness, it is possible to set an alpha value. Exactly what we're looking for. So let's reduce the value to increase the face's visibility. Back to lineup. Perfect. Both model and actress face can be seen. We can now check not only the reconstructed 3D points, but the overall movement of the mesh. So with a point selected, have a closer look. It's looking great. The squares matching precisely with the face movements. The solve therefore is proven to be correct in a way nicer visual way than before. That's it with orientation controls. More speed, more mapping, more possibilities for visual checks. Working with 3D models was never more comfortable and faster. This chapter can be summarized with a single line. Be prepared to be amazed. 3DE4 Release 5 introduces some amazing new features for 2D tracking points and modeling. So fasten your seatbelts and let's start with tracking. Here we have a project containing several reference frames. And the set within the frames should be reconstructed, which means a tedious hard work by placing many tracking points throughout the entire bunch of frames. As usual, let's start with frame 1. And search a feature worth tracking, like this pattern on the wall. So let the hard work begin. We'll be back in a few hours. Okay, you didn't really buy it, right? Me neither. Wouldn't it be nice if we don't have to search manually for this vague pattern in all frames, but instead let 3DE4 handle this? It would. So let's do it. Simply click on Track. The magic begins. 3DE4 Release 5 can find set patterns in other reference frames automatically. Isn't that great? The tracking is done on the GPU, so its speed depends on the card you have installed. And as we can see, it's really precise. It is impossible to find these exactly matching 2D positions manually that quickly. Let's choose another one. And adjust its tracking box. By the way, the outer search area was abandoned in Release 5 when tracking reference frames. this pattern will be searched within the entire image instead of just the search area, so this box was redundant. Start the second route. Again, this pattern will be searched in all frames, completely automatically. We see this pattern wasn't tracked in all frames. There are two gaps. Within these frames, it seems the 2D tracker was unable to find the set pattern. Let's examine the two and start with the first one. When zooming out, it's getting obvious very quickly. The pattern cannot be seen within this frame. It is hidden by the lamp. The 2D tracker is clever enough to skip placing a tracking point in such a case. In the other frame, well, here the pattern can be seen, but the 2D tracker somehow still couldn't find it. In such cases, 3DE4 Release 5 provides a new option for controlling the 2D tracking behavior. Have a look at parameter deep tracking. In most times, the default value of 0 is more than enough, but in some cases the tracker should spend more time on finding a pattern. With an increased value, the 2D tracker looks deeper into the image, thus increasing the chance of finding the set pattern. Okay then, track again. But wait, as we remember, there are only two untracked frames and one of them is redundant due to the pattern hidden by the lamp. So instead of using button track, which would try tracking both remaining frames, we speed things up by tracking the next frame alone. All tracked frames are keyframes, so frame 9 can be set as the new reference pattern by starting tracking with this frame. Then use button track next frame. As mentioned, a deeper tracking comes at the cost of performance. But here we go, the pattern could be found. Let's quickly check it with the help of the reference pattern. Great, this point is finished. As an alternative way, in cases a pattern cannot be found in a specific frame, and also as an additional help if even deep tracking set to 1 won't work, Release 5 provides a different approach. Remove the keyframe to restore the old status of no point in this frame. Although the 2D tracker wasn't able to find the pattern with deep tracking set to 0, we can identify the pattern. Obviously, it must be here. Okay, approximately here. Of course, that's not really precise, but a rough starting point is all we need. 3DE4 Release 5 introduces updated script align point to previous next keyframe. Since version 2, in addition to sequences, it can be used with reference frames as well. The script is executable here in menu tracking or with button align to key in display area. Either way, it works great with a new tracking engine. Simply select the script. And here we go, the 2D point was positioned precisely. In contrast to the 2D tracking seen previously, with this script, the engine only uses the area around the set point, instead of searching within the entire image. Therefore, a pattern can be found much faster, if we can set the 2D point at its approximately correct position. Some more points will be needed, so continue tracking features to reconstruct the wall. Okay, we have several features tracked throughout all reference frames. Let's calc all to see the result. Best in 3D orientation controls. Looks good. All reconstructed 3D points and cameras are positioned correctly. Alright, this result leads directly to the next great feature coming with 3DE4 Release 5, modeling. Like in Release 4, we can use the reconstructed points to create a mesh. Well, there are redundant polygons, so let's clean the model up a bit. Good. Now with footage projected onto the 3D model, we quickly see this model isn't very precise in the areas between the reconstructed 3D points. The footage on it translates happily around. Especially when having a closer look, it's not hard to see that this simple mesh is far away from an accurate reconstruction of the wall. So how do we get there? Maybe tracking many more points for more vertices? Maybe, at least if you have way too much time. 3DE4 Release 5 introduces Refined Polygons. This new feature deforms the selected 3D model based on information a sequence or reference frames provide, without any additional tracking data. In its requester, we have some options to control behavior, sources, and speed of the refining process. One option to be mentioned here is use auto-tracking masks. For this demo, we'd like to reconstruct the wall alone. But as we can see, there are a big table with a monitor and some lamps standing in front of the wall. They shouldn't be considered in the refining process, so they are masked out in auto-tracking controls. In the requester of Refined Polygons, this option ensures the masks are being considered. Okay, we can leave all other options at default, so let's start the refinement. Based on your graphics card, this might be fast or a bit slower. Nice, the 3D model changed dramatically, with dramatically better results. We quickly see the new model is way more detailed and shaped like we'd expect from the curved wall in the footage. The attributes from the source model are assigned to the new one, so footage projection is already activated. Have a look at the new result. Great, the translations seen previously are gone. All patterns and markers do not move, proving the good refinement. Of course, the differences considering blurring and brightness are coming from the different reference frames. The wall is now reconstructed accurately. So, having this great 3D model, wouldn't it be nice to have it accurately textured as well? When scrubbing through all frames, we see these annoying black areas with no image information. That would be really nice. Alright then, let's do it. Previously, we generated UV coordinates alone due to the lack of images. Now we generate a true texture map with textures and coordinates for this model with Generate UV Texture Map. This is done fast and easy. First, we set a file name for the texture. Let's say Great Wall Texture. Then define the resolution. There is no upper limit. It is possible to create really huge textures. Besides standard 8-bit format, this function also provides 32-bit OpenEXR with a high dynamic color range. Last, of course, all cameras available should be included into the texture. Button OK starts the texturing process. After a short while, a texture was created, and we instantly see the black areas are gone, thanks to all the images taken into account showing the wall from different angles. Having a closer look, we obviously don't see any transformation. It is a texture. Switching back to a footage projection, we can compare the quality of the texture. To be sure, again in a different frame. Very nice result. One more thing in the end. You may have noticed Generate UV Texture Map also provided an option to consider the auto-tracking masks to exclude table, monitor and lamps from the texture. With the footage projected on the wall, we see this huge lamp, which of course does not belong there. Back to UV mapping. Poof, it's gone. Magic. Well, not really, but it feels a bit like it, right? Okay, we have a detailed modeled and textured wall. The last step is exporting to Maya. The first thing we notice here is the updated exporter. So many new parameters. As usual, set a file name. Next, we can set which cameras should be exported. Then, for the first time, 3D models are available for export. Again, we can choose which should be considered. And it doesn't matter if it's a static or animated mesh. All models within a scene in 3DE4 are suitable for export. Further, UV texture export is now supported as well. We have such a nice texture, so yeah, we want to do this. And overscan won't be needed in this demo. We're done. Everything's ready for the Maya artists. Our job is finished. Okay, that's it with the amazing new features for tracking and modeling. Only with Release 5 it is possible to reconstruct even complex geometry without the need to track thousands of points. And even if that would be necessary, in a reference frames project, tracking was never easier and faster.